All right, before some of you, after looking at this review, go into a complete panic and go, holy cow, Hardy, is the test going to be this long? No. It won't even be half this size, more than likely. But there's a lot of stuff we've done in this unit so far. So I wanted to make sure we got examples of everything so you're not questioning things when we get to the end. I will also mention that on the quiz itself, some of the hints that are on this review will be on the test. So not only will you have the notes available to you if you've done that for any of these different units, but you'll also have some hints here and there on the test itself. But the review, lots of points. I'm going to work with it through it with you here right now, and hopefully it'll kind of refresh your memory on some of the stuff that we haven't done in a bit. Okay, so again, we're not going to do every single one, but I'm going to get you started in enough places that it should be fairly simple for you to do the parts that we're not doing together. So when we're multiplying with exponents, and notice they all have the same base, okay, multiply the coefficients and add the exponents with like bases. So if there's a number in front, we're going to go ahead and multiply that. But exponents, as long as the bases are the same, we're just going to add them up. So those first three problems basically are all the same deal. Add up the exponents, you're good. Once you get to the next portion, though, this is where you've got to be a little bit more careful. On my x's, I'm still going to add the exponents. That's not going to change. But those numbers in front, I do not add. I multiply those coefficients just like I normally would. So I end up with 15, x to the 15th. Okay. If I have multiple variables, like I do in 6 or 7, the first two rules would still apply. I would still multiply the coefficients. And with my variables that are alike, my x's in this case, okay, 3 and 8 adds up to 11. And my y's, 4 and 5 adds up to 9. And then I'm good. Okay. So again, multiply the coefficients, add the exponents. Hopefully in that time you've actually had time to do a couple of others, if not all of those as well. So then I move down a little bit. And I get to power. Distribute the exponent to all the terms and multiply the exponents. So, again, four times 5 is 20. 3 times 5 is 15. Now, can I put those together and call it 35? Okay, hopefully somebody said no by this point. If that's not the case, why can't I? Right, different bases. I'm done. Now, if you get that number in front, that coefficient, that also is going to get my exponent. Okay, so that would be 3 to the 4th. We'll come back to that in a second. And then multiply exponents for x and y. Now 3 to the 4th, be careful. 3 to the 4th is not 12. It's not 3 times 4. Remember, 3 to the 4th is the equivalent of multiplying 3 by itself 4 times, which would be 81, x to the 8th, y to the 8th. Okay. Well, what if there's a fraction? Okay, you mean something like number 11. That exponent's not only going to go to the numerator, where I'd square the 3, and 3 squared, 3 times 3 is 9. Multiply my exponents. But it's also going to go to the denominator. 4 squared is 4 times 4, which is 16. 3 times 2 is 6. And again, I don't have like bases, so I can't go any further. That's the thing that some of you've got to keep getting a grip on here. So nothing too shabby there. So then I get to dividing exponents. Okay, you divide the coefficients, but subtract the exponents with like bases. Now let me give you a reminder on this part, the subtracting exponents. There's two parts to this. You always do the big exponent value-wise minus the smaller one. And then you've got to remember that the answer goes where the larger exponent is. Okay? So for instance, if we're looking here, I guess I should give you a second to write that down. Whenever you're looking at one of these, the big issue is going to be, okay, well, I can handle 9 minus 5. Okay, that's 4. But again, the larger exponent means it'd stay up in the numerator. Okay, I don't need anything else on this one. That one's okay. But let's say I get to something like number 15 below it. Okay, there's a couple of things going on here. First, it's not 10 minus 5. We still divide the coefficients. So 10 divided by 5 is 2. Bigger numbers up in the numerator, so my 2 stays up there. Then my x's, 8 minus 2 is 6. The 8 is bigger, so my answer, my x to the 6th, goes in the numerator. And with my y's, 5 minus 2 is 3, but the bigger exponent's in the denominator. So I get y to the 3rd, and I'm done. Okay. That's the biggest thing to keep track of with these. Okay, let's try one again here. Let's try again with 16. Now, negative 24 over 10. Okay. For 24 over 10, if you're not sure how to reduce it, because again, it's not just minus and saying that it's negative 14. So, if I'm not sure, I can always type in the coefficient part and hit math, enter, enter, and I will get the simplified form of the fraction. And then I just go back to my rules. So with my x's, bigger minus smaller, 9 minus 7 is 2. Where's the bigger exponent at? In the denominator. So that's where my x's are going to go. When I do the next part, 9 minus 3 is 6, so my exponent's going to be 6 on y. Again, where is it going to go? Where the larger valued exponent is. And I'm done. Okay? So that's what we've got to keep an eye on as we're working through parts of these. Now as I head over to the next part, we have one more specific section here. Okay, 0 exponents, reminding us that anything to the 0 power always equals 1. And negative exponents need to be flipped to become positive. So for instance, if I get a problem like 19, okay, anything with a negative exponent I want to look at as a fraction, because I got to have somewhere to flip it. So by flipping that 5 to the negative third to the denominator, becomes 5 to the positive third, but I still have to have something up here in the numerator, or this won't work out well for me. So I put a 1. And if I'm not sure what 5 to the third power is, and no, it's not 15, reminder, your caret button is your exponent button. So I can do 5 to the third and get my answer. Okay, and I really don't want decimals here, so that's going to be my solution. Okay. So same idea. I'll do one more here. Let's do 20. If I have a fraction, the negative 3 would go to both the 1 and the 4. Okay, what number needs to be flipped? Both of them, you're right. 1 to the negative third flips down to the denominator. 4 to the negative third, if it starts down below, heads up to the numerator. And again, just calculate those out, whether they're on the calculator or wherever. 4 to the third is 64. 1 to the third is 1. And if you want to leave it as 64 over 1, that's fine. Now, just a couple of them down here as well in the next section. Rewrite each expression using only positive exponents. No decimals. So for instance, if I was doing number 22, okay, which parts of that have negative exponents? Well, the a and the b. Does the 3 have a negative exponent? No. Okay, if anything, it has a positive exponent of 1 on it. So do I need to flip the 3? No. It has a positive exponent. It doesn't get flipped. But my a and my b, since they both have negative exponents, both get flipped, and I'm done. Okay. Again, the only flipping is on negative exponents. So like on 23. I see a negative exponent there. We'll make this a fraction. Does negative 2 have a negative exponent? No. Just because it's a negative number doesn't mean it has a negative exponent. So that doesn't flip. What about p? No, that has a positive exponent. It has an exponent of 1 if I don't see one. Okay, what about q? Absolutely. Q is going to flip, and I'm done. Okay, so it's little things like that that I sort of have to keep an eye out for. Let's find a couple more here that are a little bit different that we may have to think about a little. Some of you are like, 24 is a good idea. Okay. So if I send that through, I've got 3 to the negative 2, x to the negative 2. But I know, since I see the negatives, there's going to be some flipping going on. What flips? Yeah, basically everything. So 3 squared, x squared. And what do I put up here if I don't have anything left? Because I got to hold the place. The 1. And the only thing left I can do now is I can figure out what 3 squared is, which is 9x squared. So just keep telling yourself, only things with negative exponents flip. And I see my one last one that I need to do. 29. Get lined up here a little better. That negative 2 exponent goes to the negative 2, goes to the 4, goes to the 3. Now the reason I chose this one is when I put my exponent on my negative 2, I'm going to put it in parentheses, and I'll show you why that's important here in a minute. 4 times negative 2 is negative 8. 3 times negative 2 is negative 6. Make it a fraction. What needs to flip? Everything. Everything has a negative exponent. So I've got negative 2 squared, x to the 8th, y to the 6th. And how do I hold my place? With a 1. And some of you still may be wondering, why do you have the negative 2 in parentheses? Let me show you. If I were to not have the negative 2 in parentheses, and I did negative 2 squared, okay, I get negative 4. Okay, that would be incorrect. I am squaring what's called the quantity of negative 2, which gets me positive 4. So this solution is actually 1 over 4 x to the 8th, y to the 6th. Okay, and that one's done. So I'll leave it to you to figure some of the rest of these out, but I'm feeling generous today. So let's look at 30. Do I need to do any flipping? Okay, only one of them. Which one? 2 to the negative 7th. So 2 to the 6th gets to stay. 2 to the negative 7th flips up. 2 to the 5th stays where it's at. Now here's the difference. We might get fooled by this since they're all numbers. They all have the same base. So let's see here. When I'm multiplying with the like base, what do I do with the exponents? Add them up. 6 plus 7 gives me 2 to the 13th over 2 to the 5th. Ooh, but I still have a like base, but now I'm dividing. So what do I do with the exponents? Subtract them. 13 minus 5 is 8. Bigger exponent up there. And I probably wouldn't think most of you know 2 to the 8th power off the top of your head. Again, use your exponent button. And that's my answer. Even if you just got to 2 to the 8th, I would accept that on a test. Okay? So that basically gets us through some of our exponent portion of things. Now there's still some parts that are left. So let me get the calculator out of the way. Okay, we're going to bust through the polynomials here. And then we're going to kind of start to slow down a little bit and give you a little bit of time to get some stuff done. So, all right, determine whether the expression is a polynomial. Then identify if it's a monomial, one term, a binomial, two terms, or a trinomial, three terms. Then find the degree of the polynomial, which again, that's on the largest single term. If I have more than one variable in a term, I can add up the exponents, but otherwise it's only term by term. So now let's go back to this whole idea of determine whether it's a polynomial. Okay. Couple of things to be on the lookout for. Remember, our big issues are negative exponents, and exponents in the denominator, which kind of goes along with negative exponents. If I run into one of those, I just say no and I'm done. So as I work through these, I look through 31 through 34 looking to see if they cover either of these exceptions. I don't see any negative exponents. I don't even see a fraction, so that one's okay. So yeah, that one's a polynomial. Negative 25, not much there, but it's not a negative exponent, it's just a negative number. So that's a polynomial. So then I get to the next one. What about 33? Oh, there's a negative exponent. That's no, and it lets me wipe the rest of this out. Now, before you get to 34 and say, wait a minute, Hardy, there's more than 3 terms there, and you didn't give us polynomial as an option. Look for like terms. Four x and x is 5x. Remember, there's a 1 there. And 2x is 7x. So this is really no negative exponents, no exponents in a denominator. This is going to be a polynomial. Now, figuring out my terms, remember, my terms get separated by these walls called plus or minus. So here, how many terms have I got? Okay, I've got 2. Which is a binomial. Okay. Here, I only got 1 term. So which one's that? Okay, it's a monomial. And what about 34? Because 33 we didn't have to worry about it. It's not a polynomial. Right. Okay. And then remember, degree is finding the largest exponent of a single term. Now, for instance, here in 31, my first term would have a degree of 1, but my second term has a degree of 1, 2, 3. And I'm always just going to take the bigger one, and that's going to be my degree. Now, 2, I don't want to say it's a trick question, but, you know, we got to think a little bit. When we look for degree, we're looking for the exponent on a variable, okay? So largest single term, exponent on variable. Well, what if there is no variable? Then what's my degree? Yep, it's going to be 0. Okay. So this one was no, so we don't have to do it. Here again, separate. I've got 1, 2, 3 terms. I have a degree of 3, degree of 1, and a degree of 0. So my biggest one's going to be 3. Okay. And we're going to continue that down into the next section. Find the degree. Again, look at these as though they're being separated by a wall count your exponents in each individual term, even if they're different variables. So 4 and 1 is 5. 1 and 2 is 3. And this one's got 5, and whichever one's biggest is my degree. So that's how that section would work. Okay. For the next part, we're going to write each polynomial in standard form, which is the largest degree, or in this case exponent, to least. It's my first job. Then identify the leading coefficient, the number that's in front, once I have it in standard form. So if I'm doing standard form for number 38, which one of the 3 terms there needs to go first? X squared. Largest degree, has the biggest exponent. What would be next? Yep, 5x. Because your constant term, your number is always going to have a degree of 0. It's always going to come last. But don't stop there. Identify the leading coefficient. What number's in front of x squared? If I don't see a number, we consider it a 1. Okay, so I'll write that down. Let's say I'm doing 39. Again, which term's going to go first? Now, hopefully, you said negative 4x squared, because the sign that's in front of the number is important. It has to be there. And I just work my way down. Second power, first, and my constant term. And once I get there, look for that number in front of my first term. But they have to be in the right order first. If they're not, that'll get messed up. Sums and differences. Here, basically, I'm just combining like terms. So here I'm like, okay, I got positive x squared and negative x squared. Well, they cancel. That's cool. Now, be careful. Y squared and y squared. We're not multiplying here. Okay, we're not going to mess with the exponents. Do not mess with exponents. We are not multiplying here. Just combining like terms. So if I have 1y squared and I add another one, how many have I got? 2 of them. No change of variables. So let's say you get to like 43. Okay, what's the same? Now I realize these both have xy, but this has a squared on the y. That matters. That makes them different. So if I'm looking, I'm like, okay, oh, there's another xy squared. Watch the signs, though. That matters. It's not just 6 plus 10. Just because I'm combining like terms doesn't mean it gets bigger. If I got $6, ooh, but I went and spent 10, I'm 4 in the hole. If I have 4 xy's and I find 2 more, I have 6. And again, notice I'm not messing with the exponents. And then I got my lonely y squared down here at the end. And I'm set. Okay. The only thing that I find really can set people off in this section, or the thing that sets them off the most often, is an issue like you run into in 44. When there's a minus in the middle, I need to distribute that through. So I leave the first part alone. I can drop the parentheses, but I change the signs on each of those. So I'm not trying to figure out what minus and negative and all that stuff is. Once I've done that, I can go back and combine the terms that are alike. Okay. And I'm done. Now, I'm going to give some of you a little bit of a head start here, just in case you've kind of been blowing through this as we go along. A lot of you have got sheets still that I need to get from this last section we've been doing on growth and decay. You know, if you don't have some of those, grab them from the folders over along the wall, and you can work on those with some extra time that you have. Now, the few of you that actually are completely caught up and have all the worksheets in, okay, because the last day that I will take worksheets from polynomials or exponential growth and decay is Monday. So if you're not sure, look at the back board. That's where all of those assignments are listed, and try to find those. Whatever I have left of extras is in the folders over there. So just in case some of you are rolling along here, though, I'm just going to do one example of each here on the part 2 that we'll be doing into next week, just so you've got something to work with. So like for instance here, let's say we were looking at 51. I'd distribute through, and again, I'm just multiplying the coefficients. This is a -2 that I'm distributing. Negative times negative is positive. And are there any like terms I can combine? There sure are. 15 minus 2 is 13a. -10 and +6 is -4. And I'm good. And the last thing I'm going to put in here for you, I'll keep that up there for a second, is finding the product down here at the bottom. Now again, some of you are very comfortable just using FOIL and using the lines. I'm fine with that.
I brought your book.
But just in case you're having, firing ahead here some more, when we're trying to find the product, I'm not just multiplying the first things and the last things together and calling this like x squared minus 20. And I talked to some of you before about using a little organizational tool called a box to make sure you multiply everything together, and it also does your like terms for you. So remember, my exponents are 1 if I don't see 1. So x times x, add my exponents. X, or 1x, times 5 would be 5x. -4 times x is -4x. And -4 times 5 is -20. And again, if you just start in the upper left-hand corner, I get x squared. My like terms are together. Again, watch the signs. 5 minus 4 is 1. You can put the 1 in front if you want to, but you don't have to. And a -20. Okay, so you've probably got somewhere in the ballpark of 20 minutes to keep working here. Well, again, whether it's in this packet or it's in one of the polynomial or exponential growth and decay worksheets, keep firing away, because our test for this will be in the middle of next week, probably Wednesday or Thursday.